What does it really mean for an AI to think? Today, we're diving deep into Interview.net fundamentals. .NET 8 reshapes enterprise computing. Cloud native and AI workloads demand deep runtime literacy. Hiring screens now probe GC heuristics, async state machines, middleware topology. Syntax recall alone no longer suffices. The new standard is system-level reasoning. Interview.net Fundamentals is the architecture-first preparation system that builds a causal mental model of the entire stack. But here's where it gets interesting, the interview gap. Candidates recite theory but cannot trace an HTTP request from Kestrel through middleware to output. Rote memorization collapses when interviewers ask, why does async void crash? Existing resources isolate features. None connect the stack. The missing piece, a unified operating model of .NET. Without it, every question feels disconnected. So what's the real problem? Let's talk about root cause, fragmented learning. .NET education treats features as silos. Async taught without the task CQger context, DI without service light-time resolution graphs. Middleware explained without pipeline branching or short-circuit rules. Isolated knowledge fails under cross-cutting interview probes. The interview demands mental traversal across layers. This raises a critical question, breakthrough, a layered operating model. View .NET as 4 interconnected layers: runtime, language, application, design. Every interview question maps to a layer and its interactions. Instead of answering trivia, you reason from first principles. The model turns a flat list of topics into a navigable, causal system. Now, let's zoom in on the system. Interview.net fundamentals. A modular preparation framework that builds a complete mental model in weeks. Diagnostic assessment identifies layer gaps. Layer depth modules, cross-layer synthesis challenges, and mock interviews that simulate real architectural probing. Designed for engineers who need to pass system design and deep dive rounds. Here's something most people overlook: system architecture. 4 layers. Runtime fundamentals, GC generations, JIT tiers, thread pool, starvation, value type semantics. Language mechanics, async, state machine, expression trees, generics reification, pattern matching. Application model, ASP.NET Core pipeline, middleware ordering, DI lifetimes, options pattern. Design and architecture solid, CQRS, domain-driven aggregates, microservices, communication patterns. Think about this for a second. Preparation pipeline. Diagnostic pinpoints weak layers with runtime-focused scenarios. Layer-by-layer deep dives build causal understanding, not syntax lists. Synthesis challenges force cross-layer reasoning, e.g. trace a request from Kestrel to database. Mock interviews replicate real why and what happens if questions. Feedback loop refines the mental model until traversal is instant. And this is where things get complex. Layer 1, runtime fundamentals. GC modes, workstation versus server, background GC, large object heap compaction. JIT, tiered compilation, REU-JIT, when methods are promoted. Threading. Thread pool injection, task versus thread, async state machine allocation. Value types, stack allocation, boxing triggers, defensive copy pitfalls. But here's where it gets interesting. Layer 2, language mechanics. Async await, compiler-generated state machine, synchronization context capture, configure await ball. LINQ, deferred execution, expression tree versus delegate, Aquartech boundaries. Generics, reification, covariance, contravariance, open versus closed types. Modern C record equality, init-only setters, pattern matching exhaustiveness. So what's the real problem? Let's talk about layer 3, application model. Request pipeline, Kestrel middleware chain endpoint routing. Middleware, order dependency, short-circuiting, branching with map/use when. DI, scoped versus transient versus singleton lifetimes, captive dependency detection. Configuration, providers merge options pattern with iOption snapshot for hot reload. This raises a critical question: measurable impact. Pre-post assessments, 3 times faster interview readiness, 60% less study time. 89% of candidates report deeper architectural intuition. Success in system design rounds rises sharply. Candidates reason about trade-offs instead of reciting definitions. The layered model becomes the internal debugger for every .NET problem. Now let's zoom in on evolving with .NET. Continuous updates aligned with .NET 9, 10, and beyond. AI-assisted gap detection prescribes layer-specific modules. Community-curated problem sets keep the model current with real-world interview trends. Live architecture walkthroughs turn passive knowledge into active reasoning. The fundamentals model adapts. The system grows with the ecosystem.